Okay, so we're going to take a look at the Leaving Cert Higher Level Maths 2020 paper 2. So this exam was on yesterday, and I'm just going to have a look at it and see what we think of each question. I think overall the paper was okay. There was one very difficult looking question, and we'll get to that. I'm not going to do any solutions. I'm just going to have a look at the questions, and I'll do a solutions video for it in the next week or two. So let's jump into question one. Question one there, coordinates of 3 points, A, B, and C. Find a perpendicular distance from A to B, C. So that's just your perpendicular distance from a point to a line formula. And then based on your answer, what can you conclude about the relationship between A, B, and C? So I'm kind of guessing that maybe the perpendicular distance is 0 and therefore they're collinear, but without doing it, I don't know what it will be, but that would be my guess. If the perpendicular distance isn't 0, then we have to conclude something else. Part B then, the diagram below shows two lines A and B. The equation of A is x minus 2y plus 1 equal to 0. The acute angle between A and B is theta, that's this angle here. The line B makes an angle of 60 degrees with the positive sense of the x-axis. Find the value of theta. So for this one, I think you need to find the angle over here between the line A and the x-axis. Then you know this angle here is going to be 120, so you can find the angle here, which is vertically opposite to theta. So that's not a bad question at all. Question 2, the circle C has an equation x squared plus y squared minus 4x plus 2y minus 4. The point A is the center of the circle. The line L is tangent to C at the point T, as shown in the diagram. At the point B, 5, 8 is on L. Find the length BT. So find the length from here to here. So for this one, I think you're going to have to find the center of the circle. That'll be A. You can then find the distance between A and B. And using your distance formula, then you can find the distance between A and T. That'll be the radius. And then Pythagoras should get you the distance BT. Part B, two circles C1 and C2 have their centres on the x-axis. Each circle has a radius of 5 units. The point 14 lies on each circle. Find the equation of C1 and C2. So I'd start by drawing a sketch for this one. These two circles are going to intersect, and the point 14 is going to be the point of intersection of the circles. And I think then you can do something with the radius being 5. And then distance from this point 14 to the center is obviously going to be 5 as well. You might get some triangles. You're going to look for the center of each circle from that diagram. I think you should be able to do it using triangles somehow, and then once you have the center, you have the radius of each of them, and you'd be able to find the equation of both of them then. So might be a little bit of work in it, but it doesn't look too bad. Question 3 then, a flagpole GH is shown in the diagram. It's vertical and the ground is inclined at an angle of 5 degrees to the horizontal between E and G. The angles of elevation from E and F to the top of the pole are 35 degrees and 52 degrees respectively. The distance from E to F along the incline is 6 meters. How far find how far F is from the base. So that's F. Find how far F is from the base and give your answer correct to 2 decimal places. So this is just a basic trigonometry question. You should have done ones similar to this before. So you'd be using maybe your cosine rule, your sine rule, etc. To find these angles and sides here. So shouldn't be too bad. Part B. In the diagram, the large circle S has center O. The small circle C has center D. The circle C touches the circle S at the point C. OA and OB are tangents as shown. They're tangents to the small circle. The radius of C is R. This angle here, BOA, is 60 degrees. the ratio of area of S to the area of C, so that's the area of the big one to the area of the little one, is K is to 1. Find the value of K. So for this, I think you're going to find the area of the small circle, obviously in terms of or, because you don't have any length. But then if you can find the radius of the big circle in terms of the radius of the small circle, so find this OA or OC in terms of or using triangles and trigonometry or geometry. And if you can do that, then find the area of the bigger circle in terms of or and put them as a ratio to each other, and that should give you K. Question 4 is find the two values of theta for which tan theta over 2 equals minus 1 over 3 or 1 over root 3, where theta is between 0 and pi over 4. So that's just your standard trigonometric equation that you should have done. Part B over here, a little bit trickier. The diagram OAB is a sector of a circle of radius 7 centimeters with center O. In the sector BOA, the angle is 1.2 radians. You're not usually going to get a radian angle as a decimal like that. It's usually in terms of pi, but it's 1.2 radians. The area of the shaded region is 21 centimeters, square centimeters, and find BC. So find this length here, BC. So for this one, I'm thinking you find the area of the whole sector, then take away this area, and that'll leave you with this area here of this unshaded region. Then you can maybe use the area formula in reverse to find OC, and then take it away from 7 to find BC. Question 5 then, onto your probability. Two events A and B are such that the probability of A is 3/4 and the probability of A intersection B is 1/2. Find the probability of B given A. Give your answer as a fraction in its simplest form. So you have your probability formulas to help you with that one. Then part 2 of it, find the probability of the probability of A union B is 11 over 12. Investigate if events A and event B are independent. So you have your independent events formula there to go and have a go at that one. Part B, a spinner consists of 4 segments. Each segment is equally likely to be landed on. Liam, Circa and Lee play a game in which the spinner is spun twice. The numbers landed on are added together, and then the result is divided by 3, and then the remainder is recorded. So if the remainder is 0, Liam wins. If the remainder is 1, Circa wins. And if the remainder is 2, Lee wins. Is the game fair? So it's a very awkward game, but the probability in it isn't too difficult at all. All you have to do is work through each of the probabilities of getting a remainder of 0, a remainder of 1, and a remainder of 2. So if it's spun twice, the largest value you can get is 6. So find the probability at the smallest you can get is 2, and then you can get things in between. So just find the probabilities and see, is it fair? Question 6 then, a bit more probability for you. A class group carried out a study of the makes and fuel types of cars in a large car park. 30% were diesel and 70% of these were Volkswagen. 60% ran on petrol and 25% of these were Volkswagen. And 10% were hybrid or electric and 9% of these were Volkswagen. One car is selected at random. Find the probability that it's a Volkswagen car. So for this you can just do 70% of 30, 25% of 60, 9% of 10%, and then that'll add them together. That'll give you the percentage of Volkswagen cars. So your percentage then will be your probability. Part B then, Road Safety Authority has data on a driving test pass rates for its test centres. In a particular driving test centre, the probability that a person taking the test for the first time will pass is 1 over 4. All of the tests are independent. In this centre, on a particular day, Joe, along with 5 others, take the test. All 6 are taking a test for the first time. find the probability that Joe passes along with exactly 2 others. So for this one, it'll be a quarter. That's the probability that Joe passes. We want him to pass, multiplied by the number of different ways that 2 others out of 5 can pass. So you just use your formula. That'll be 2 pass, 2 fails. So quarter to the power of 2 and 3/4 to the power of 3, and 5 choose 2. Part 3 in this one, the overall pass rate for all drivers at another centre is a half. So this is whether it's their first attempt or a subsequent attempt. On a particular day, n people take the test in this centre. Find the probability that 2 people or less than 2 people will pass the test. Show that it can be written in this form here. So for this, I think you want to find the probability that everybody fails. So that'll be a half to the power of n. The probability that 1 fails, probability that 1 fails would be a half to the power of 1 times a half to the power of n minus 1, and the probability that 2 fail will be a half to the power of 2 and a half to the power of n minus 2, and then you're going to be adding them together, something along those lines. I'd have to just write it down to be 100% sure that I was saying that right, but it's going to be something along those lines, and then see if you add the fractions together, do you get that there, or something in that form, obviously, and find A, B, and C. Question 7 then was a fairly long question. A right circular cone. So hopefully you would have dealt with these before. A company makes a biodegradable paper cup in the shape of a right circular cone. Each cup has a radius of 3.3 centimeters and a slant height of 9 centimeters as shown. Show the vertical height of the cup is 8.37 centimeters. So you're just using Pythagoras there for that. Find the curved surface area of the cup, correct 2 decimal places. You got a formula for that in your log table, so you should be able to do that. The diagram shows a net of the cup. Find in degrees the size of the angle theta. So we have the area of this from part 2. Use your area of a sector formula in reverse to find the angle theta. Part B. In order to avoid spillages, each cup is marked with a dotted line at F, which is 1 centimeter vertically below the top of the cup as shown. Find the volume of the water in the cup when it is filled as far as the dotted line, and give your answer correct 1 decimal place. So you have the new height, but you need to find this new radius. So you're going to need to use similar triangles to find this length, or so use similar triangles and then use your volume formula there to find the volume. Water flows into the cup. Water flows into one of these cups through a cylindrical pipe of radius 0.8 centimeters at a flow rate of 2.5 centimeters per second. Find to the nearest second how long it will take to fill the cup. So you're going to have to find how much water goes in per second. So pi r squared times 2.5 will tell you how much water goes in per second, and then divide your volume that you got in the previous part by how much goes in per second, and that should give you the answer then. And then on to part D on this one. The company decides to change the position of the line F in order to limit the capacity of the cup to 60 cubic centimeters. How far vertically below the rim of the cup should F be drawn? Give your answer in centimeters, correct to 1 decimal place. So similar to the last couple of parts, except I think you're working in reverse. So you've got the volume and work backwards from that. So might be a little bit of work in that part, but hopefully you can get through it. Again, we'll have a solutions video coming later on this week or next week. Question 8 then, this is the one that I think is quite tricky. There's a lot in it, and it's worth 70 marks. It's a big question, and without putting pen to paper, it's tricky enough. So I'll have the solutions for it coming out in the next couple of weeks, but for now let's just take a quick look. An airline company, Trans Sky Airways, has designed an aptitude test for people applying for jobs as trainee pilots. The aptitude test is scored out of 500 marks. The results are normally distributed with a mean score of 280 and a standard deviation of 90. The top 25% of people taking the aptitude test are invited back for an interview. Find the minimum mark needed on the test in order to be invited back for an interview. Looks tricky enough. I'm thinking something along the lines of if you can convert 25% into a Z score, so maybe something along those lines, and then you'll be able to figure out the marks from there using your standard deviation of 90. So I'll just have to have a bit more of a think about that. If you have any input on this question, certainly let us know in the comments. Anyone who scores above the 40th percentile can resit the test later. Eileen scored 260 marks in the test. Find out whether or not Eileen is eligible to resit the test. So you need to find what the 40th percentile is and see, is it greater or less than 260. So if it's less than 260, then she can resit the test. The next bit, part B, so first a small little explanation. Explain the relevance of the Z scores minus 1.96 and 1.96 in the standard normal distribution. So hopefully you recognize those numbers and you should be able to explain it. Part 2, Trans-Sky Airways surveyed 2,500 of its passengers about a new service it proposed to introduce. The variable p hat is the proportion of respondents in the survey who said they would use the new service. The radius of the 95% confidence interval of the survey was 0.01568. So find the value of p. So you need to set up your 95% confidence interval, but you know that the difference between the highest value and the lowest value is this here. So it's kind of working a little bit backwards from that. But you're setting up your confidence interval formula is what you're using there. Part C, then, the weight of the airline passengers' carry-on luggage is normally distributed with the mean of 12 kilograms. The airline has recently introduced a fee for non-carry-on luggage. After the fee was introduced, the airline expected the mean weight of the carry-on luggage to change. They selected a random sample of 80 passengers and weighed their carry-on luggage. The sample mean was 13.1 kg and the sample standard deviation was 4.5 kg. Test the hypothesis at the 5% level of significance that the mean weight of the carry-on luggage has changed. State the null hypothesis and the alternative hypothesis and give your conclusion in the context of the question. So this is your standard hypothesis test. You have everything that you need there. Now, students do sometimes find these tricky, but you have everything you need there to get it. So just do your hypothesis test and see if you can reject it or fail to reject. Part D then. The company bus can carry passengers up to a total maximum weight allowance of 3,000 kg. The weight of passengers is normally distributed with a mean of 73 kg and a standard deviation of 12 kg. 40 passengers board the bus. Find a probability that the total passenger weight will be over the maximum weight. Give your answer correct to 2 decimal places. So what I'm thinking for this one is divide 3,000 by 40 and see what the mean weight of these 40 passengers is. It's probably more than the 73, and then whatever it is, you want to find the probability of a person being that weight, and then find the probability of 40 people being that weight. Perhaps there might be another way to look at it. That's just kind of what I'm thinking there at the moment. If you have any ideas, let us know below. And then the last bit, part E, a list of 8 whole numbers. They are labelled from A to H as shown. The numbers are all greater than 0 and are ordered from smallest to largest. The difference between any 2 adjacent numbers is 2 or more. The median of the list is 12.5. The lower quartile, that's the median of the 4 lowest, is 7.5. The interquartile range is 12. Second largest number is 23 as shown. The range of the list is 21. That's the difference between the first and the last. And then the mean is 13.5. Find all the numbers. So this is classic problem solving here. I think first of all, I'd start with the mean is 13.5. I know there's 8 numbers, so I can find out what the sum of all the numbers is, and then that might be a starting point that I can go from. And you're just going to have to try and check off and one number at a time here for this. So I'd say it's something that you just need to kind of get stuck into and see if you can get a couple of numbers and go from there. So that question 8 I think was a difficult enough question. It might turn out to be a bit easier once I go and have a look at doing actual solutions. So we'll have a look at that soon enough. And then on to question 9. 2 ships set sail at the same time, ship A from port A and ship B from port B. Port A is 90 kilometers due west of port B as shown. Ship A is travelling due east at 15 kilometers per hour. Ship B is travelling due south at 30 kilometers an hour. Find the distance between the 2 ships 30 minutes after they set sail. Give your answer in kilometers correct to 2 decimal places. So you need to find out how far A has travelled in half an hour. Find out how far B has travelled in half an hour. And you're just going to use trigonometry there to find the hypotenuse of that triangle. T is the time in hours after the ships set sail. Show that the distance between the ships at time t can be given by the function, this one here. So I think for that, basically you're doing the same thing as above, except you're doing it in terms of t rather than 30 minutes. And they give you the function there, so hopefully you should get that. So it'll be Pythagoras, and you can see that this is something to the power of a half, so that's the square root. So that's finding the hypotenuse of a triangle. And then part C, use calculus to find the value of t when the ships are closest to each other and the distance between the ships at the value of t. So that's just going to be your max min problem, so minimum value for the closest distance for that. So that's the end of that paper. As I said, question 8, probably the hardest looking question so far. The rest of them I think should be okay. I'll have a solutions video done for this paper hopefully within the next couple of weeks. So thanks for watching, and I'll see you next time.